Good morning, good afternoon, good evening, and good night. My name is Jeremy Anthony Gunawan. I'm from the class Numerical Method 1, and I'm going to present about the synopsis of my final project. The title of my final project is Design Optimization of the Battery Capacity for UAV Delivery. So, what is this project about? My project is about uh, drones. So, drones in the past have been used as military surveillance and weapons and that kind of stuff. But nowadays, drones are mostly used as a recreational device. Some functions are like aerial photography, light shows, or even useful stuffs like mapping out woodlands and delivering medical supplies with ease. Um, these drones are mostly used nowadays as a delivery device where it can deliver a package within minutes just before ordering and paying online. A big e-commerce company called Amazon has started doing this since 2016. They have created drones that are capable of bringing up to 2.2 kilograms of package and has a top speed of up to 80 kilometers per hour. Now the challenge is if the drones are able to deliver multiple packages in one certain radius of area and delivering it with the right battery capacity so that it can fulfill the needs of the delivery efficiently and effectively. Now it could be a challenge because the weight of the package could affect the battery of the drone. So this project aims at using programming or Python at finding the best battery capacity according to the parameters that I've given in this project. So the parameters are the drone distance, maximum drone distance, drone speed, and the total package mass that is delivered. So let's get right into the introduction. So drones are widely used in industries, leisure activities, as I said before. Now they're equipped with various sensors such as GPS and wireless communications and sensors, and they are able to perform such amazing functions such as photography, autonomous flight, and such things. I've been, from what I told before, Amazon, the big and the giant e-commerce company, has started doing the drone delivery since 2016, and um, they they are still developing it. But the challenge is about the for drone deliveries. The challenge is the lithium-ion batteries, which um, currently only allows about half an hour flight. Battery capacity is crucial to the service of the system, which is drone delivery, because without batteries, the drones can't operate. Now, it is crucial to consider the parameters or the characteristics that is that is affecting the battery capacity of the drone. So, by improving the battery capacity, the drones have may have an increased amount of performance, which can increase even the company's service. So this study particularly focuses on um, serving on an individual drone which delivers multiple packages in a certain area with a certain radius. So in the methodology, there are certain variables that describe the battery capacity of the drones, such as maximum drone distance of the delivery, drone speed at which it is going, and the total package mass that it is bringing, and it includes the drone weight also. Now, these tests are critical factors to the battery capacity, which I will tell you about later, and several factors that affect actual applications like weather conditions, government regulations, and safety issues such as like drones should fly below 400 feet or 500 feet and below 100 meters per hour. So these things are not considered in this project solely because this project aims at finding the most optimal battery capacity for the drone. So the objectives are: one, to find the most optimal design of the drone by considering its constraints and requirements, and to optimize the battery capacity for drone delivery based on its parameters. So to find the most optimal battery capacity for the drone, there are some constants that we can assume as the same number throughout this project. So the total work hours for individual drone per day, which is W, is 6 hours, and the mass of the drone, the total mass of the drone is 10 kilograms. The power efficiency of the motors and the propeller is 0.75, the standard, and the lift to drag ratio of the UAV is also standard, which is 36.48, and the area of coverage of the radius of the drone area coverage is 56.25 pi. Now, the ANPAC variable is the average number of packages carried by the delivery drones within their maximum allowable payload. We assume that one package has a weight of 0.5 kilograms per package. To measure the D, which is distance, which is the total distance of the multiple demand points that are visited by a single vehicle in one tour, an expert has created a formula where A, B, and C are constants in a 100 times 100 square catchment, where A is 3.63, B is 85.78, and C is 62.67, where K is a constant, and given it is 0.16 considering the size of the service area. So the formula is D equals to K, which is the constant, times A times N pack, number of packages, plus B times N packages plus C. Next, T is the total time spent by an individual drone in completing a tour or a delivery. L is the line haul distance, meaning the distance for a drone from to make a trip from the depot, from the home to the specified area and back, which is why this is 2L, because it takes the drone to go to the specified area and then back home. And then V is the speed of the drone. For the drones to make the delivery, the battery capacity determines everything about the service. The equation below here is formulated drone energy consumption considering various factors like the number of packages, the total mass, which means the mass of the package plus the mass of the drone, times the speed of the drone, times T, which is this, the total time spent by a single drone completing multiple deliveries, divided by 370 times the efficiency, which is the power transfer efficiency of the electrical motors and propeller, and the lift to drag ratio of the drone, times 100%. Next, the first constraint represents the maximum number of packages that each delivery can hold. The average number of packages carried by delivery vehicles within their maximum allowable payload, where the combined mass of battery and parcels should be less than 2/3 of the total mass of the drone. As you can see, this is the constraint. The next constraint is the maximum delivery range. So the sum of the total distance, which is the distance of the multiple delivery and the line haul distance, has to be less than equals to double roots of the area of coverage divided by pi. The total distance of the drone can't exceed the limited service zone radius, enabling the delivery drones to complete a round trip in the service area only. And the last constraint is the maximum time of delivery per day for one individual drone. The sum of the total distance divided by the speed of the drone is less than equals to the total work hour of one drone per day, which is 6 hours, and the drone work time can't exceed its limit per day to work to according to the drone longevity number. Now the expected results is the optimal combination value of maximum drone distance, drone speed, and the total package mass. These variables are expected to show the most optimal design during drone delivery. These are the references that I use for this particular project. I hope you enjoy my synopsis. Um, Thank you for listening and watching.